choosing inputs. People think, well, you know, well, we can always understand what these algorithms do at the end of the day. That's just not true. Even if you can see a piece of code, I ask you a simple question. Does this piece of code compute a function f of n equals n plus 1? Simple question. Here's a piece of code. Doesn't do that. You can't tell me with absolute certainty whether it does or doesn't do that. In fact, you can't run a test to verify whether it does, and you can't run a test to verify whether it doesn't. You're screwed. So if you can't verify whether this piece of code is adding 1 to an integer, what chance do you have of understanding what an arbitrary piece of code is doing that may stretch over tens or hundreds of thousands of lines? And if you think that's bad, good luck with the 10,000 by 10,000 machine-learned parameter matrix for an algorithm, because that's what machine learning does. It computes a massive parameter matrix and uses that to process data. It's not lines of code in the sense you're used to. So here's a giant grid of numbers. Tell me what that does. No comments in that code. I think, well, maybe, you know, leaving code in the open, like open source, solves the problem. In 2012, an upgrade to OpenSSL was put out. Had a small bug. It's called heartbleed. 2 years later, even this was in the public domain. 2 years later, somebody noticed. It's considered one of the worst security bugs in recent times. Microsoft went back on its no update policy to update Windows XP because of this. It basically allowed you to read arbitrary strings in the RAM. So you can pick out people's cryptographic keys, passwords, everything. Pretty bad bug. Sat there for 2 years as a piece of open source software. No one noticed. No one was incentivized to look for it. So don't think that the magic white hat vetting fairies are going to vet your code if it's in the public domain. So you can't understand code, good luck with the matrix of numbers, and don't expect the public to find errors in it either. But surely Google knows what their algorithms do. Right? When they design an algorithm, they must definitely know. They're so crazy smart, and they have so much data and money. You know, there's no way that Google's algorithms will start putting UK government adverts next to extremist content on YouTube. There's no way that would happen, except when it happened 3 years ago. Their algorithm was doing probably what they intended it to do. But the outcome of that was that UK government paid for adverts. What the hell UK government advertises? I don't know. Stuff. Look how good the government is. Look how much money we took from you this week. Whatever they do. And join the police, even though there are no jobs. And join the fire brigade, and there's no jobs. So these ads were next to extremist videos on YouTube. And the government was quite rightly pissed off. And Google said, oops, must have been a bug. Well, no, I'm sure that the algorithm was doing exactly what they had designed it to do. It's just no one realized that that sort of combination of stuff would make the algorithm happy. And we're treating these things as people, right? They can vote. Criminals can't, people in jail can't vote, but the algorithms can. You go figure that out. So I have a serious concern about algorithms and AI. Firstly, bias can be really hidden. Right? And a naive person might think that we can easily find bias. In fact, I went to a government-sponsored event a few months ago where a member of the Science and Technology Committee was taking questions from young researchers, and one of the questions was about algorithmic bias. And he said, yes, this is important, we realize there's algorithmic bias and we have to deal with this. And I'm thinking, okay, great, they're thinking about this, they're doing so, this government is understanding the problem. He said, yes, so we need to write algorithms to find the biases in your algorithms. Fucking idiots. Help. That's what the people at the highest level of government are saying. This is the Science and Technology Select Committee. We need to write algorithms to find the biases in our algorithms. Mate, you can't even find f of n is n plus 1. And this is absurd. You appreciate this is absurd, because now it's another algorithm. Who writes the algorithm to find the biases in the algorithms? Well, someone. But they might be biased. So we need to have an algorithm to check the bias in the algorithm, check the bias. Do you see where this is going? Define. Well, I'm sure it's on the bi-Lipschitz map between two metric spaces. Okay, so we're stuck with bias because people design algorithms. We're stuck with understanding what these things do. We're relying more and more on AI. But surely we can just turn AI off. If it all gets too messy, we'll push the off button. What's one computational process that we can't turn off? You've heard of this. Come on. Blockchain. Exactly. What's something you can do on blockchain now? We can do this via Ethereum, actually. You can execute code. You can execute code to do trades. Ethereum. People are using AI to design the code to figure out which trades to execute on Ethereum. You commit this to the blockchain, you can't turn it off. So all of a sudden, the maxim of, well, if it gets too messy, we can just turn the AI off, is now broken. The effects of it are stuck. What are you going to do if you're a clever bit of code and those trades on Ethereum start sending money all sorts of places you never thought it would? If it starts taking money from places you never thought it would, all of a sudden your little piece of code is sending money to extremist groups. You can't stop it. Sorry, on the blockchain. Too bad. Should have thought about that. So the only thing we can turn AI off is now rubbished. This worries me. The other thing that worries me is the danger of when algorithms meet algorithms. This is something that people have not fully appreciated yet. When my algorithms meet your algorithms, shit's going wrong. Stupid example, happened on Amazon. There were two booksellers, second-hand booksellers. One of them had a really high rating, and one of them would always try to be the cheapest seller of a book. So they would look at all the second-hand books for sale of that title, and they would undercut by 5%. Another seller had a hugely high satisfaction rating, whatever it was, hundreds of thousands. So they would look for the cheapest book and add 12.5% or 13% to that. Then they'd buy from it, if they could not, they bought it from the cheapest one and then sold it on. And they made a 13% profit, minus internal costs. There was a case when these two sellers met on a book. And they were the only two sellers in the market. The book, which cost £12 new, reached £13 million second-hand. It wasn't a good book either. 13, because it just kept chasing. Right? My algorithm meets your algorithm. I think my algorithm is clever. You think your algorithm is clever. They get together, splat. So, oddly enough, only one of them changed their algorithm. So one of them said, no, this is ridiculous. So just brought the price down to whatever it was, £8. And the other one left their algorithm, so it was £8 plus 13%. And the reason, so this is actually discovered because somebody analysed the price movements, and it was always, they saw the 13% jump and then the 5% catch up each time. So that would be what the two algorithms are doing. So if algorithms are messing up when pricing a second-hand book, what happens when your self-driving car meets his self-driving car on the road? Have you thought about that? Do you have any trading data for two self-driving cars against self-driving cars? You've learned that against people. And people do people things. Human prices. A person pricing a second-hand book on Amazon is never going to go, £12 million, I think that's fair. So your algorithm tries to outsmart a person. Your algorithm tries to outsmart a person driver. What happens when your two algorithms meet on the road? What happens if you get to some crazy configuration where all of a sudden all the cars in the road think, shit, something's gone wrong, and they all turn left. And you don't realise it's happened until it happens. That scares the bejesus out of me when algorithms mean algorithms. Because we don't have a full understanding of what's going on. And again, if we can't predict this, how do we predict that? We have another example of algorithms meaning algorithms, which is the way that YouTube makes video suggestions. They have a video suggestion algorithm, which decides how to give you videos that make you want to click on them more, because the point is to get you to watch more videos. And your own internal brain is running an algorithm on what it likes to watch. Who here has ever gone to YouTube and said, you know what, I want to watch a really balanced and fair debate between two fairly equal sides on an important point? 2 hands go. Who here has gone to YouTube and said, I want to watch something that's really fun and agrees with what I believe and is totally aligned with my sort of value system and everything like this? This is what we like to watch. This is the equivalent of watching a car crash on a racing track. People go to the races to watch the crashes, not the boring, well-driven laps. Same thing on YouTube. Content that triggers more of an emotional response gets more hits faster. To the point where the BBC will put up a clip on a piece of news, and someone else has some sort of clip that put up, maybe from their wobbly smartphone or something, or they got some commentary over the top of it, and the BBC one doesn't get suggested as much as the other one. Because it's got some more of an extreme-ish sort of spin, or an emotive spin. So this is YouTube's algorithm, designed to give you stuff that you want to watch more. And people do this. They watch more and more and more, and they spin into these vortices of echo chambers. I like this stuff, I get suggested this, I get suggested this, and then I start spinning inside this sort of vortex of maybe 100 or 200 videos, round and round and round. So if you only go to YouTube and you watch sports videos, you keep getting suggestions of people, hitting the baseball over the edge of the field or something like this. And you spin around and around and around in that. You never break out. So YouTube is giving people stuff that is polarizing them. Maybe it's polarizing in a fairly stupid way. I just keep watching baseball videos and never watch any football videos. I like baseball more. But it might be polarizing them politically, or in some sort of other social way. You think, well, people have free choice. We'll just make an algorithm, and they enjoy the algorithm that we've made, and so they have free choice to keep using it. They can choose not to. Okay, well, but at the same time, people have free choices to, what sandwiches they buy for lunch. So set up a little sandwich store which sells sandwiches with cocaine, spread it throughout the middle of the sandwich. And they're a free choice. They can have as many cocaine sandwiches as they want. The point is that actually, people can become addicted to things. People can do things that aren't necessarily good for them. And if you provide that and make it really easy, someone sitting at home, click, 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 click. What's the brake mechanism? What stops them from taking this from doing this too much? Okay, maybe one little triangle of cocaine sandwich is not so bad for you. But what if you're having a whole loaf of them? Okay, this starts to affect people. Just saying that someone's free choice, without explaining to them what the negative effects might be irresponsible. And this is YouTube's algorithms bumping into what people like and enjoy, what we feed off, our addictions, what gives us pleasure, what we like to see, what stimulates us. This is another example of algorithms bumping into algorithms and seeing what happens there. I said something that's under-addressed. Is mathematics impartial? Yes, but you're not. Our own internal bias, coming from our own experiences, our own lessons, and our own cultural influences, impact how we design and create systems. And can often lead to the creation of bad systems, even without our intention. Into every system we create, into every algorithm we write, into every model we come up with, we pour all our prejudices, all our ignorance, all our cultural norms, all our moral beliefs, all our subconscious aspirations. That is where we want to go, and where we want the world to go. We create tools of great power, but how that power is wielded is influenced by its creator, by the way we design these systems. Often too much honour, or valour, or impartiality is applied to mathematics, is assigned to mathematics. And we defer our personal moral judgments, which we can claim to be flawed, to the purity of mathematics, which we claim is impartial. Mathematics is impartial, but its creator is not. This doesn't seem to be well understood by mathematicians. If you go and read Science News from 2016, there's an article called Fighting Terrorism with Mathematics. And someone says, modelling data is an economically cheap option that lets the data speak for itself, extricating the researcher's emotions from the equation. Who designed the equation that takes in the data? The researcher. Who designs the model? The researcher. Who designs the incentives for the AI? The researcher. Who picks what data to put in? The researcher. There is no way to extricate yourself from the process. You're built into the process from the very beginning. It's just not that obvious that you are. And here's a question that we can talk about when we get to discussion. If a mathematical process makes a moral decision, who do we hold morally accountable? Mathematics? You're going to burn a book if something goes wrong? Using mathematics to decide who should go to jail is power. Using mathematics to determine elections is influence. Using mathematics to do things like cheat emissions testing by algorithms, which is what Volkswagen did, that's harm. So how in the hell is any of this fair or impartial? So I think I'm done for my main presentation. Thank you.